So this is, I hope, the third lecture of satellite communication. In our previous lectures, we have started with the laws of planetary motion. With three laws of Kepler, we have discussed. From that, we have balanced the two forces so that a particular object can rotate, keeping some point at the center. So that balance force was centripetal and centrifugal forces. With solving, we derive the expression of velocity at which any particular object is moving in a particular orbit, and that orbit is having a radius r. Further, we also considered circular orbit. We derived the expression of time period at which a particular object, the object is satellite for our purpose, and we have established a relationship that the square of the time period is directly proportional to the cube of the radius of a particular of the orbit in which a object or the satellite is rotating. So that was the third law of Kepler, or the third law of planetary motion. And henceforth, we also have considered an elliptical orbit. And for elliptical orbit, we derive the we have studied the expression of velocity and the time period. Further, we took an example of different orbital height. We have to consider three orbital heights: 1,000 kilometer, 20,000 kilometer, and 40,000 kilometer. And I asked you to find out the velocity. So this you can find by using the third law of Kepler, or third law of orbital motion, planetary motion. So using that, if you find, then you will get the values, the velocity like this. So we had a conclusion at that point. If the satellite is rotating at a particular orbit having less orbital height, that means it is understood the satellite is moving at a very high velocity. In other way, if a satellite is moving at a larger orbital height, then the velocity of that satellite is slower. So with that, we had a conclusion that means the lower orbit satellite goes out of visibility for a certain duration of time. So in order to avoid that kind of problem, so we have discussed two things can happen. So either we can launch many satellites. So many satellites can be launched in a particular orbit, such that if this is the visibility of this particular satellite and your Earth station is located here, when this satellite moves to this particular position, then this Earth station will not be within the visibility of the satellite. So that at that particular point, a new satellite will come to this location and your Earth station will remain within the visibility of the current satellite. So this will happen. So if you are launching more than one number of satellite and all satellites are rotating in that particular orbit, so a continuous coverage in between the satellite and the ground station can be established. And this is only for lower Earth orbit satellite. That means if the satellite is rotating at an orbital height which is very less. Otherwise, there is another option. If the satellite and Earth station, suppose this is the Earth station, ES, or the ground station, you can call it as GS. This is your Earth. Your Earth is rotating around itself. So accordingly, the Earth station, which is on the surface or on the ground of the Earth, it is also rotating around the Earth or the center of the Earth. So if the satellite rotates at the velocity which is equal to the velocity at which the Earth is rotating around itself, then only the relative stability can be established between the satellite and the ground station. So suppose this ground station is moving at a velocity v, and at the same velocity, if your satellite will move in its orbit, then these 2 points will be relatively stable, so that a continuous communication can be established between the Earth station and the satellite station. So this is one possibility. Okay, so we had two possibilities discussed, and we discussed that the orbital period, that means the time taken by the Earth to move around itself, should be same as the time taken by the satellite to move 360 degree. So that means when this Earth station completes 360-degree rotation, for the same time, this satellite should complete 360-degree rotation for the same time. So from that we discussed when any point on the Earth complete 360-degree rotation, we understand that is called a day. So from that we discuss what is a day, and we have two different days. One is called a sidereal day, another is called a solar day. Sidereal day means once a point on the Earth's surface, suppose this is a point on Earth's surface, if it completes 360-degree rotation, so that time duration is called a sidereal day. But solar day is different. That means if this point, which is facing directly to the sun, again when this point faces directly to the sun, so that time duration is called a solar day. So solar day is 24 hours duration, that is 86,400 seconds, whereas sidereal day is less than that duration, which is 23,056 minutes and 4 seconds. So that is equal to 84,164 seconds. So for satellite communication, we use this particular value, that is called the sidereal day. We are not using the solar day. So you all have to remember this value, because this value we will be needing, using in many examples in our further problems or examples. So you have to remember this value, that is the value of one sidereal day as a unit of second, or otherwise you can remember 23 hour 56 minutes and 4 seconds. And from this we also have answered a particular question. The question was, what is the orbital height of a circular orbit satellite with period of a sidereal day? Okay, so that means if this is your Earth, this is the Earth, and the satellite is moving in a circular orbit around the Earth, okay, and the satellite takes a time period that is of one sidereal day to complete 360-degree rotation, then what is the orbital height of that satellite? So orbital height means at what height from the ground station or from the Earth surface the satellite is orbiting. This is Earth, so this is Earth surface. So at what height that orbit in which your satellite is rotating. So we have to calculate this. So what is given? The time period of the satellite is one sidereal day. That means to complete 360-degree rotation, this satellite takes one sidereal day of time. That means T is equal to 23 hour 56 second, so 56 minute and 4 second. This much time the satellite takes to complete 360-degree rotation. So by using the third law of Kepler, we can find the value of R, because T is this value. Mu is a constant which we have discussed in previously, 4 pi R constant. So you will get this value. So this is the R. So we got the value of R. So R means what? R means from the center of the Earth to the satellite orbit. This is called R. But the question is to find the orbital height. So orbital height is nothing but R minus the radius of the Earth. So radius of the Earth is 6,378 kilometers. So this value you have to remember. Nobody is going to tell. So this is a fundamental question. What is the radius of the Earth? 6,378 kilometers. So if you subtract this value from the obtained R value, then you will get the orbital height. So orbital height is 35,786 kilometers, which we approximately we call it as 36,000 kilometers. Okay, so the exact value is 35,786. That means when we talk about a satellite which completes 360-degree rotation at a time of 36 hours, 56 minutes and 4 seconds. At the same time, any point on the Earth's surface takes the same time to complete 360-degree rotation. That means the satellite and this particular point, they are relatively stable. So as the Earth rotates and the satellite rotates, they will always point to each other. At every point, the satellite and the ground station, they will point with each other. So there will be all-time communication or all-time direct to direct link can be possible between the ground station and the satellite. So which satellite, for which satellite it is possible? It is possible for those satellites which are orbiting at an orbital height of 35,786 kilometers. So since these satellites are moving with a synchronization with the ground station or the any ground point, so those orbit is called geosynchronous orbit, or it is in short it is called GSO. So this orbit is called geosynchronous orbit, or that is called GSO. So again I am telling, geosynchronous orbits are the orbits in which the satellite, okay, I am making some conclusion. Geosynchronous orbit is an orbit in which the satellite is moving at a velocity that is same as the velocity at which the Earth is rotating around itself. This is one point. The second point is the geosynchronous orbits are the orbit which are or which is located at an orbital height from the surface of the Earth at a distance of 35,786 kilometers. Okay. So when the orbital plane is same as equatorial plane, then for an observer on the Earth's surface, the satellite seems to be a stationary point above the equator. Okay. So what I mean to say, this is the Earth. This is the Earth. Okay. So when we discuss in the previous slide, we discussed about the geosynchronous orbit. So geosynchronous orbit is the orbit which is located at an orbital height of 35,000 or around 36,000. So this orbital height, so this orbital height this orbital height can be here. This orbital height can be here. This orbital height can be here. So your satellite can also move in this particular orbit where the orbital height is 36,000 or that is exact value is 35,786. Okay, here also it is 36,000. Here also it is 36,000. Here it is 36,000. Here also 36,000. So that means at any inclination, okay, any inclination, the geosynchronous orbit is possible. Understood the point? And here also I also can draw another orbit like this. So this can be also 36,000 kilometers. So this line states that if this line states that if the orbit or if the orbital plane is same as the equatorial plane. Okay, so what is equatorial plane? Let me show the Earth. Picture of a Earth where I have yeah, you can see this is the Earth. So this is called the equator. This particular line is called the equatorial line. So what is an equator? Do you know? Equator means it is the line which is at 0° latitude. You know what is latitude and longitude. So these particular horizontal lines, these are called the latitude. So this is 0° latitude. This is 15° latitude. This is 30° latitude. This is 45° latitude, 60°, 70°, and finally this will be 90° latitude in north. Similarly, it is 15° latitude in south, 30° latitude. Which one is 30°? This particular line, if you see, this is 30° latitude in south. This is 45° latitude in this particular line. Similarly, 60°, 75, and finally this is 90° latitude in south. Similarly, you have longitudes. So if you see this particular line, it is called the 0° longitude. So 0° longitude passes through which? Greenwich. We call it as the Greenwich Mean Time. So at that particular point, the 0° longitude has passed. And here similarly, towards east, this is towards east, and this is towards west. So the longitudes are marked like this: 15° east longitude. This line is 30° east longitude. This is 45° east longitude. This is 60° east longitude. So unlike this, it will have 180° east longitude. Similarly, in this side, you have 15° west longitude, 30° west longitude, 45° west longitude. So on like that, you will have up to 180° west longitude. So here it is 180° east and here it is 180° east. So the whole circle, it will be 180 degree plus 180 degree, it will be 360 degree. So total angle is 360 degree, which is divided into different longitudes. So half of longitudes are 180 degree east, half of the longitudes are 180 degree in west. Similarly, the latitudes are also divided in two parts. Some latitudes are north, some latitudes are in south. So 0 to 90 degree, it will go up to north. Similarly, 0 to 90 degree, it will latitudes will go up to south. But if you note here, our country, India, which is located here, okay, our country is located here, which is locating towards the north of 0 degree latitude. So 0 degree latitude is called the equatorial line. So this is called the equator. Equator means it is the line of 0 degree latitude. Okay, so our country is located towards the north of 0 degree latitude. So in the very beginning of the introduction class of the satellite communication, I asked you one question, that why the DTH antennas are facing towards, or they are tilted towards south. Okay, so why they are tilted towards south? I will answer that question in today's lecture. So understood what is equator? So equator means it that represents the 0 degree latitude. Okay, so what is equatorial plane? Equatorial plane means, suppose this blue color circle is your earth, okay, and this particular orbit, okay, where the plane of this orbit is same as the plane of equator, then this particular orbit is called equatorial orbit. Okay, that means what will happen? The satellite will rotate like this, rotate along the equator. Again, it will go back side of the equator. Okay, so in the equatorial plane, the satellite will rotate. So it is difficult to draw the three-dimensional thing of that. You can consider this also. Suppose this is the earth. Consider this one is the earth, the red one which I have drawn as the earth. So this particular line is the equatorial line. Okay, that means 0 degree latitude. So this plane, okay, this plane is called the equatorial plane. Okay, exactly. If you see the inclination of this plane with the latitude, if the inclination will be 0 degree, then this is called equatorial plane. Now look at this particular plane. This particular plane. What is the inclination? The inclination is this one, W. W is the inclination. This one. Okay, this much. Correct, understood. So if the inclination will be 0 degree with respect to the latitude, or 0 degree latitude, or if the inclination is 0 degree with respect to the equatorial line of the earth, then that particular orbit is called GEO orbit. That is called geostationary orbit. Okay, so what is the relationship in between the geosynchronous orbit and geostationary orbit? So geosynchronous orbit are the orbit in which the satellites are rotating at a velocity. Okay, as I have mentioned here, 3 different points about geostationary orbit. Okay, GSO. So what is the nature of geostationary orbit? The orbital period is one sidereal day. That means the satellite takes 23 hour, 56 minute and 4 second time to complete 360-degree rotation around the Earth. So that orbit is called geostationary orbit. Second point, it should be in circular orbit. So geostationary orbits, stationary orbits are the circular orbits. Okay, now if so geostationary orbits can be, can be one geostationary orbit, this can be another geostationary orbit, this can be another geostationary orbit, this can be another geostationary orbit. So one more point I'll add here is that geostationary orbits are located at an orbital height from the surface of the Earth that is equal to how much? 36,000 kilometers. This is the another property of geostationary orbit. They are located at an altitude from the surface of the Earth, 36,000 kilometers. But all geostationary orbits are not, so all geosynchronous orbits are not geostationary orbit. Okay. In case of geosynchronous, both ground station and the satellite, they are moving at the same velocity. That means there is a synchronization between the satellite and the ground station. Or if that GSO orbit, if the inclination angle in between the geostationary orbit and the 0-degree latitude or the equator is 0 degree, then that orbit is called GEO orbit or geostationary orbit. Okay. Listen the terms very carefully, because whatever we are going to discuss that very important and very conceptual and things to be analyzed within you, because the three-dimensional picture is very difficult to draw here. So you have to analyze it. Okay. So as I repeat it again. So this is one GSO orbit. This is another GSO orbit. So there can be many GSO orbits are possible at different inclinations. Okay. Different inclination. There can be many GSO orbits are possible, but if the inclination angle of the GSO orbit is 0 degree with respect to the equatorial plane. Okay, which is equator? This is equator. Okay, or the equatorial plane is like this. This is the equatorial plane. That means if you take the sphere of Earth, make completely cross section, take the cross section of that, then that plane is the equatorial plane. At the center of the Earth, if you cut the Earth, then that plane is called the equatorial plane or 0 degree latitude plane. Okay, and if your satellite is rotating in the same plane where the angle of inclination of this orbit on the equator is 0 degree, then those satellites are called geostationary satellite, or the orbit is called geostationary orbit, or that is called GEO. Okay, so if we compare between GSO and GEO, every geostationary orbit is a geosynchronous orbit, and there can be only one geostationary orbit, but there can be many geosynchronous orbit. The orbital height of geostationary orbit and geosynchronous orbit are same. Only difference is the geosynchronous orbits can be of many with different inclination angles with respect to the equatorial plane, whereas the inclination angle of geostationary orbit with respect to the equatorial plane is 0 degree. So note the difference between geosynchronous orbit and geostationary orbit. Okay, so all the INSAT satellites. So INSAT stands for Indian National Satellite. In short, it is called INSAT. All INSAT satellites are placed in GEO orbit or geostationary orbit. So INSAT satellites are for communication purpose. That means television communication purpose. We are for educational purpose. India has launched INSAT satellite, and INSAT have many series. INSAT satellites, they have many series. So they are launched particularly in GEO satellite. Correct. So INSAT satellites are called geostationary satellites. Now, if we go back to that image of the Earth here. So as I have said that all INSAT satellites are rotating in GEO orbit. So GEO orbit means the orbit is on the equator. Okay, like this. This is called the GEO orbit. The orbit is just with 0° inclination angle with the 0° latitude plane. Okay, so your satellite is located here. Your satellite will be located here. Here in the sense, don't consider the satellite is on the Earth surface. No, it is not on the Earth surface. It is at an altitude of 36,000 kilometers from the ground surface, but at the same plane of equator. Now, our country, India, is somewhere here. If you see, can draw, you can see this diagram. The Sri Lanka is here, India is here. Okay, this is our country, India. Now, you note here, the satellite is located towards the south of India. Correct. So that is the reason why when we are using the or we are installing the DTH antenna on the rooftop, we just make little bit tilt towards the south. Okay. So what is the angle when we are bending it little bit south towards the south? It is the reason is that the INSAT satellites are located on the equatorial plane, and equator is towards south of India because India is located north of equator. So we make the antenna face towards the satellite. So that's why they are tilted little bit south. Then question come, how much angle we have to tilt? So that person who is installing the DTH antenna, he has no idea. He's a common man. So what they are doing, they will keep on rotating like this. At what point they got a good signal, they will fix that. Okay. So here we shall calculate what should be the angle of that tilt. How much angle we have to tilt so that we can establish a good communication or good signal strength, or we can make a proper communication between the satellite and our DTS antenna possible, or so that our DTS antenna can face directly to the INSAT satellite. So we are going to find out what is the angle of inclination. So here we observe that yes, why it should be focused towards the south. But if it is focused to south, then at what angle it should focus towards south. Okay, so come back. So this is the answer to the question when I asked from the very beginning why the DTH antennas are facing towards or tilted towards south. Okay, so hope you understood the difference between GSO and GEO satellite. So now I will take to some other point. Yeah. Now suppose the orbit is an equatorial, orbit is an elliptical orbit. Okay, look at this orbit. This orbit is an elliptical orbit. So in elliptical orbit, it is not a pure circle. Okay, this is the satellite and this is our Earth. This point is called the center of the Earth. And if you note here, the elliptical orbit, the Earth is not present at the center of the ellipse. The Earth is present at one particular site or close to one particular orbit. So this point, which is away from the Earth, this point is called apogee, and the point which is close to the Earth, this point is called perigee. And this point, red mark point, represents the center of the Earth. Now, from center of the Earth to the apogee point, this distance is denoted by RA. From center of the Earth to the perigee point, this distance is represented by RP. Now, from this, we can find out the eccentricity. Eccentricity is nothing but the RA value minus RP divided by RA plus RP. But if we consider this as a circular orbit, so what should be the value of eccentricity for circular orbit? The value of eccentricity will become 0, because in circular orbit, the Earth is located at the center. So RA is equal to RP. So RA minus RP will become 0. So eccentricity for circularly orbit is equal to 0. And one more term, that is, we call it as the semi-major axis, that is RA plus RP divided by 2, which is denoted by A. So A represents the semi-major axis, that is of this value. Okay, I hope you understood till now. Yeah. Now, look at this particular diagram. In this diagram, you have the Earth and the satellite is located somewhere here. Then question comes, how we can find out what is the location of the satellite? Understood the point? Means suppose satellite is somewhere here. The satellite can be on the equatorial plane. The satellite can be at an angle, inclination angle, or satellite can be located in some other point, can be located in LEO, can be located in MEO. But how we can say that the location of the satellite is at this particular point? Or in other sense, how we can find the location of the satellite? So look at this particular diagram. This is the image of Earth, and this dotted line represents the 0-degree latitude. Okay, so that is called the equator of the Earth, and your satellite is located somewhere here. I have considered a random point where the satellite is located. Now, the line joining between the Earth's center to the satellite, that point is called the sub-satellite point. If you make a straight line from the satellite to the center of the Earth, and that line will intersect the surface of the Earth at some point, so that point is called sub-satellite point. So keep a note of this term, sub-satellite point. Okay, so when we look to the Earth from satellite, so that direction is called nadir. When we look the satellite from the Earth's surface, this direction is called zenith. So nadir direction is the direction from satellite to ground station. Zenith direction is the direction from ground station to the satellite. Okay. So one way to represent the satellite by using the coordinate system. So we can use 3 different coordinates, X, Y, and Z axis, and we can represent the coordinate of the satellite. But it is better to represent the satellite location by using a different coordinate system. So that coordinate system is well known, that is called the latitude and longitude. So we find the location of the satellite by using the latitude and longitude. So then it is not the latitude and longitude of the satellite, rather it is the latitude and longitude of the sub-satellite point. So what we observed, or what we have noted, this line joining from the center of the earth to the satellite intersects the ground surface at a point. That point is called sub-satellite point. This sub-satellite point will have some latitude and longitude. So whatever the latitude and longitude of sub-satellite point is, so we call the satellite is located at that particular point or at that particular coordinate or at that particular location. So if the satellite is a GEO satellite, if the satellite is a geostationary satellite, or if the satellite is a geosynchronous satellite, let me write over here. If the satellite is a geosynchronous satellite, okay, listen carefully. If the satellite is geosynchronous satellite, that means it is located here. And suppose this point is having the coordinate which is equal to 56° north and 23° east. So this is the latitude and longitude of the sub-satellite point. Okay, then what is the location of the satellite? You just make a line joining the center of the earth to the subset, because you know the location. The location is this value. So make a line joining, and by this line joining, you will extend up to what? Because it is a geosynchronous satellite which is located at an orbital height of 36,000 kilometer. So from this point, from the sub-satellite point, you extend this line at an height of 36,000 kilometer. So that is the location of your GSO satellite. Understood? Now I will ask, what is the location of geostationary satellite? Then what is the location of geostationary satellite? What is the latitude and longitude of geostationary satellites? Keep it in mind very carefully. You listen. The latitude of geostationary satellite will be 0°, and the longitude of geostationary satellite can be some value like x degree north, x degree east, or x degree or y degree west. All geostationary satellite will have 0° latitude. Why it is? Because the satellites, the geostationary satellites, they are rotating on the equator, and equator is having 0° latitude. So this dotted line represents the equator. It has 0° latitude. So if you want to ask me what is the coordinate of this, it is 0° latitude and some degree east. Suppose 90° or 98° east. Similarly, this has the coordinate 0° latitude, 98° west. Okay, so this is how the equatorial line is represented. It is always the latitude will be 0°. So on this equator, the satellite is not moving on the Earth's surface. It is rotating on the orbit, and the orbital plane is same as the equatorial plane. So the GEO satellite will always have 0° latitude. They will have some longitude, but they don't have any latitude. The latitude is 0°. Okay, so now you can see one of the satellites I have taken an example, that is GSAT-3. It is at 83° east. So what is the value? What is 83? What this value is given? This is nothing but the longitude value is given. It is not the latitude, because latitudes are neither north or south. East west means these are the longitudes, and here the latitude is not given, because it is well known. If latitude is not given means, then by default you have to assume that it is a GEO satellite, and the latitude is 0°, and it is 83° east means, so this particular line represents 0° longitude. So east means this side. In this side, it is 83° east. So the satellite is located somewhere here. Okay. So that is the conclusion, that GSAT-3 is a geostationary satellite. Okay. So hope this discussion is clear to you. If you have any question, you can ask me quickly.